The graph of y equals x sine pi x for values of x from 0 to 1 is shown below. On the diagram above, shade a region whose area is equal to the integral from 1/6 to a half of x sine pi x dx. So we just need to go from 1/6 to a half, and that is the area that we are going to shade. By considering the areas of rectangles shown in the graph of y equals x sine pi x above, demonstrate and explain why the value of the area that we shaded in part A is more than 1 plus 2 root 3 over 72 and less than 3 plus root 3 over 36. And this has got to be to do with adding the areas of rectangles that are under, so these ones, and the rectangles that are over, which we'll come back and look at shortly. So we can see the width of each of these is 1/6. So we have 1/6 times 1/12 for the area of the first rectangle, that one there. And then we're going to add 1/6 times root 3 on 6, which is the height of the second one. So that gives me 1 over 72 plus root 3 over 36, which is 1 over 72 plus 2 root 3 on 72, which is 1 plus 2 root 3 on 72, which is this. Okay, then we're going to look at the over rectangles, which is the area of that added to the area of that. So that is going to be 1/6 times root 3 on 6 plus 1/6 times a half, which is root 3 on 36 plus 1 on 12, which is root 3 on 36, add 3 over 36, which is 3 plus root 3 on 36, which is that. State one suggestion as to how the approximation from part B could be improved. And this is a fairly standard sort of answer. What you want to do is use more rectangles. You want thinner rectangles, and then if you have thinner rectangles, more of them, the areas that you cut off become smaller. So for example, with this rectangle here, you counted, so I'm talking about the rectangle that goes like that, you've not counted the area that I've shaded purple there. So if you make thinner rectangles, you cut off less of those areas. So use more rectangles and make them thinner.